In this video, we're going to prove the following fact. A cylinder of radius r and height h has a volume of pi r squared times h. And we're talking about a right cylinder. Now we're going to prove this twice. You get to choose which proof you like best. In fact, in the comment section, please state which proof you like the best. Now, the first proof, we are going to do the following. We are going to rotate this line around the x-axis. And we, of course, are going to get something that looks like that. This is going to be the radius, that distance. That means that this height from y equals 0 to y equals r will be r units. And this distance down here, that's going to be the height of the cylinder. That is, we start at 0 and we end at h. So let us find the volume by integrating. So basically, we have this slab that we're going to rotate around our x-axis, and that distance is a delta x. So it's r, the formula is pi times r squared, in this case dx, and the pi I can bring out in front, and in fact r, the radius, is just r. You can even bring out the r squared. This r initially, so let's just write it down more formally, because I'm using little r to mean two different things. It's pi times the radius squared dx, and x is going between 0 and h, because these slabs, they start at 0, a little bit more than 0, more than 0. Eventually, it goes up to h. The x goes between 0 and h, and pi is pi, but the radius in our case is just r. So it's r squared dx from 0 to h. Pi r squared I factor out. The integral of dx is just x from 0 to h. And I get pi r squared times, well, first I plug in h minus, then I plug in 0, and what's in the brackets just happens to be h. And there's proof 1. The volume of a cylinder really is pi r squared h. Okay. Proof number 2. Proof 2. So, x and y. Suppose I have a circle there with some thickness. And then I add another circle with thickness. Same size circle. with thickness. And I add another circle with some thickness. And I add another circle with some thickness. In the end, I will get a cylinder. The radius is going to be r. That is, this distance will always be from negative r to r. And this vertical distance, that's going to be the height of the cylinder. It starts at a height of 0 and it goes up to a height of h. So the volume is going, so let's look at the delta V. What is the volume of one of these? Well, it's a circle, pi r squared, times a thickness, a delta 1. So we're going to add these all up. So we're going to add them all up. On the left, we just get V, and on the right, we get the integral of pi r squared dy. And y is going from 0 to h. Now, pi r squared is just a constant. So it's just the integral of dy from 0 to h. And just like before, this integral is just h. So once again, the volume of a cylinder is pi r squared h. I'm not making this stuff up. Okay, that completes this video. Remember, in the comments, state which video you like, which proof you like the best. Or maybe state a different proof that you like.